Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more on equations with the Batty Boffin, and today we're doing something a little bit different. In all the previous films we've been solving, which means find the value of x that makes the equation work. You will notice in here, apart from the fact there's no x's, there's no numbers either. These are some formulas, you might recognise some of them. We've got Pythagoras there, we've got area of a circle there, we've got the equation from physics over there. What we're going to be doing today is rearranging these equations, and it is exactly the same as solving, okay? Totally exactly the same maths. The only difference is instead of ending up with a number to come out the end, you end up with a formula to come out the end. Now, you would say to me, why Batty, why would you want to do that? You've got a formula. Well, yeah, you see that formula, which involves speed of things, it says your final speed is equal to your initial speed plus whatever happens to change it, that's acceleration and time, okay? So v equals u plus at, and if you happen to know the initial speed, u, and you know a value for a and a value for t, then you could put those numbers in there, crank the handle, and the answer for your final velocity would come out the end. Easy peasy, very, very useful. But what happens if you actually don't know those things? Perhaps you know the final speed, the initial speed, and the acceleration, and you want to know how long does it take to go from 2 meters per second to 5 meters per second if you've got a particular acceleration, say of 1.5 or something like that. How do you do that? How do you get t if you know all the other things? Here's how. Rearranging. So we are going to rearrange this to find t. T is the thing we want. So if you think back to when we were solving equations and we had x was like the prize in the middle of the pass the parcel and it was wrapped up with layers, it's exactly the same here. T is the prize in the middle of the pass the parcel and it's wrapped up in layers of a and u. Okay, imagine that these were all numbers and that was an x. It would then be just a simple two-stage linear equation, and that's how we're going to do it. So imagine our t is the prize and it's wrapped up in two layers. We've got an add u layer and we've got a multiplied by a layer. Using our BIDMAS, BODMAS, PEMDAS thing, we know that the times layer is kind of closer in than the add layer because multiplies and divides come before adds and subtracts. So this is our closer in layer and this is our further out layer. So we're going to do exactly the same as we would if this were numbers. First thing we're going to do is get rid of the outer layer, which is an add u. We do that by taking away u. This is exactly the same as we're doing if we were taking away 4, okay? It doesn't matter if it's a letter or a number. U actually is a number. It's just we don't know what it is yet. So that's fine, we're just going to use the letter to put in there and we fill it in with a number when we know what it is. So it is still exactly the same as like take away 4 from each side. So the left hand side becomes v minus u and that equals at. Okay? Now we're going to get rid of that a layer by doing a divide by a. So the left hand side becomes v minus u over a. Or you could write that as v minus u divided by a, but make sure that you put that in brackets, okay? Has to be in brackets, otherwise the divide's just dividing the u and it's got to divide the whole thing. So either one of those two things equals t. And there we have a nice formula. So you can put in your value of v, your value of u, and your value of a, and you'll get t out of the end. For this one, I'd like you to rearrange that until it says a equals blah. Okay, so pause the video and have a go with that now. Now don't be frightened about the squares in here, okay? They work no problem at all. Looking at our a, the closest in layer is the squared. That's the I of BIDMAS, I for index, the O of BODMAS, O for order or other stuff, and the E of PEMDAS, exponentials, that's squares and square roots. That's the closest in layer. The next layer is an add b squared. Okay, add b squared. You can do that a whole one thing. You don't need to worry about squared in there. B is just a number, b squared is just a number, so it's just add a number. Okay, so what we're going to do is, rearranging that, we're going to take away the b squared. So a squared equals c squared minus b squared. You may recognise that as the formula, the version of Pythagoras you use when you're finding one of the shorter sides. So that's long side squared, take away a short side squared, gives you the other short side squared. But we need to go a stage further than that on here. We've got a squared, the opposite to that is a square root. So a equals the square root of c squared minus b squared. Be careful how you write that, make sure you are square rooting the whole thing. You could use brackets if you wanted on that there. Okay, so hopefully you got something that looks remarkably like that. Final one over here, we've got a very famous formula, a equals pi r squared. Okay, that's the formula for area of a circle. It's got that weird symbol in it. Not a problem, that is just a number, okay? Pi is just a number, like 4 or something like that. So you can just treat it exactly the same as you would normally. And this one here, I'd like you to make r the subject, please. So pause the video, have a go at that now. Right, let's look at the layers of that. Again, the first one is that squared layer. And the second one is that multiply by pi, which is just a number and you can just leave it with its symbol there. You don't have to write it out or anything. So the first thing we're going to do is to move the pi by doing a divide by pi on both sides. Gives us a over pi equals r squared, and then the opposite of square is square root. A big square root over all that there. Okay. Alternatively, you could write that as a divided by pi, square root of that, and put it in brackets if you want it. That's a really ugly looking pi there, isn't it? Okay. Any one of those ways of writing that is acceptable. Probably worth noting here that because we've got a square root, of course we've got two different answers on here. Hopefully you know that whenever you square root something, you're going to get two answers, the positive version and the negative version of it. Quick recap if you're not happy with that there. The square root of 9 is 3 because 3 squared is 9. But there's another number that squares to 9 as well. Negative 3. Negative 3 times negative 3 is also 9, positive 9. All squares are positive. Any number you square comes out positive. I use a little thing to remember here, people. All squares are positive. We draw a square and we draw a plus in it. It looks like one of those little windows. All squares are positive, even negative numbers. So negative 3 squared is positive. Okay? So when we square root 9, we say, what number when you square it gets 9? And the answer is 3, or negative 3. So the square root of 9 is positive or negative 3. So we've actually got two answers on here. So when we do this, okay, let's say when we did c squared, take away b squared, and the answer came out to be, say, 16. Okay, so we have to square root 16. So that means that a would be the square root of 16. So in the a in that case would be 4, or negative 4. There's actually two answers. Same down here as well, there are two answers. Now, to be honest, usually we only want one of them, because if we're doing this with Pythagoras and we're looking for the length of a side of a triangle, clearly we want the positive number. You can't have in Euclidean space a triangle who's got a side of length negative 4 centimetres. So clearly on that case we're looking for the positive ones. And if we're doing this with the area of a circle and the radius, again, clearly for the radius we're wanting the positive number. So generally on these cases, the positive one is the one we're wanting, because the negative one doesn't make any sense if you're dealing with dimensions on here. But just do bear in mind that whenever you're square rooting a number, there are in fact two answers. Slightly strange for maths having two answers that are right, but it's the way it goes on here. Okay, so that's it for this rearranging equations for this video. We're going to come back in the next video with a few more things for you to rearrange. I'll see you then, Batty fans.
Mwahaha! Mwahaha! Mwahaha!